All right, so here we are. We're going to finally do trig with a calculator, which is fabulous. I'm going to do it all with a TI-84, I think. I might switch to an 89 just to kind of show you how to do stuff. Now, there's some basics as we're doing this. Whenever we're looking at a, what is this thing called? A triangle. Whenever we're looking at a triangle, the thing across angle B is called side B, and the thing across angle A is called side A, and the thing across the hypotenuse is C. So you're pretty cool with A squared plus B squared is C squared, but in particular to know that side A is opposite angle A and side B is opposite angle B, just in case this comes up later. I can't remember if it does or not, but you know, you never know. I feel like that is not as bright and pretty and happy as it could be. Is this better? Oh gosh, no, that's a wee bit terrifying. Hold on. I think it's really critical that we get the perfect, happy, not terrifying color, maybe. Anyway, how was your day? I've had all kinds of fun with puppies, unsure if they want to follow basic household sanitary rules. Okay, so here we go. Solving the right triangle. Just basic idea that if we've got something like A, B, or if it says capital A, lowercase c, sometimes you'll see people that'll do lowercase for angles and uppercase for the sides and whatever, but just kind of to know the idea that whatever you're looking at, whatever's opposite is named the same thing, I guess. So if you're going to draw this out, go pa-choo, pa-choo, pa-choo. All right, so A is 325, so these are probably sides because there's no degree symbol. So 325 and 923. Now, without too much pain and suffering, I can be like, oh, okay, so c squared equals a squared plus b squared. Yay! And we're kind of amazing that we can do that. All right, so we got ourselves a little calculator. We've got 923. Ooh, that's not a 3. 3 squared. I guess I should do that slightly different, but that's okay. 325 squared. And then I can take the square root of that, and I get 9.79-ish, and that's beautiful. So C equals 9.79. All right, 9.79. Now they're also going to be asking us specifically for those values inside of the angles. So remember, this side was A. So A is opposite angle A. And B is opposite angle B. Okay, so we've been fine getting sides before. That was trig. We were fine. I mean, that was, yes, basic geometry or whatever. And now we're going to try doing trig. So we have all the sides. We can use any of the trig functions we want. I'm assuming we're going to go straight for sine because that's the one we can use without thinking too hard. So sine of, let's just say A, is going to be given by the opposite over the adjacent. So if I look here, A is, no, that's not what it is. No, it's not, sweetie. No, it's opposite over hypotenuse. Yes, it is. Opposite over hypotenuse. Okay, sorry. So it's opposite over hypotenuse. So the opposite is 3.25. And the hypotenuse from A is 9.79. So I can pull out my calculator somewhere over here, wherever I put it, and I can be like 3.25 divided by, now my recommendation is if you can do this on your calculator, don't say 9.79, okay, don't do that. Does this have a backup button? I don't know how to use I always use my 89 because I'm a big girl. I'm going to come over here and I'm just going to use that entire value so that I can get as much of it as possible. So it's about 0.332. So in order to get the actual value for A, I can take the inverse sine of both sides, which gives me that A is equal to the inverse sine of 0.332. Now I'm going to do this and I'm going to get an answer. Oops. Doop. Okay. For me, it's little second button inverse sine thingy. Yours might say A sine for arc sine. I'm going to go back up. If you don't have the ability to go back up, use as many sig figs as you can because ultimately it can get a little sensitive. All right, so I got 19.5 4. So equals 19.4 degrees. Now, always, I should have done this before I even started, you want to check and make sure that you are in degrees. Now, I happen to know that the sine of 30 degrees is 1/2. So if I go through here and I just check sine of 30 degrees, do I get 1/2? Yeah. Okay, so just to kind of give you an idea of how this could have been wrong, if I would have been here in radians, if I would have done sine of 30, it would have come back with something super weird. Okay, so then I would have known I'd gotten that wrong. So the reason I care is if I'd plugged that in while I was in radians, it would have said that my angle was 0.33 something strange. Okay, so you definitely would, oops, so much for that. You definitely would kind of know if something strange was happening, but that's why you always want to go ahead and check. So I'm gonna go back to degrees, and just because I'm a crazy person, I'm gonna go ahead and get my C as the square root of 9.23 squared. No, that's not a squared, that's a squared. Ah, I'm just making it worse. Sorry. The square root of 9.23 squared plus 3.25 squared. Beautiful. And then adjacent over hypotenuse would be the other one, right? So I'm running out of space. Okay, so I know that the cosine of, and I can just stick with the cosine of A, is adjacent over hypotenuse. You can really use any trig function you want. So the cosine of, wait, why am I doing A again? I don't care what A is. I already figured that out. I'm a crazy person. I'm gonna go back to B. Now I want B. Okay, B is opposite over hypotenuse. I'll just do sine again. What's wrong with me? Sine of B is opposite over hypotenuse. And you're like, but, I can just do this minus 90. I know we can do that minus 90. I'm doing this to make sure I didn't do something stupid here. If I was really clever, what I would do is I would use tangent, because tangent uses specifically the numbers I was given in the original problem, which is opposite over, what is that thing called? Adjacent? Opposite over adjacent. And that way, if I somehow calculated the hypotenuse wrong, then this will tell me. You know, so all these numbers should all come out and all be in agreement, and if they don't, this will tell me if I did something wrong. So I'm going to go back and use my original numbers. So the tangent of B is going to be the opposite, which was 923, and you don't have to do this. I'm just doing this because I'm a crazy person, over 3.25, so it turns out I didn't need that after all. So the tangent of B, or B, is equal to the inverse tangent of 923, and I'm just doing this to show all my steps for the moment, over 325. Isn't that beautiful? So inverse tangent, and let me make sure I still have the sine of 30 is still 1/2. Okay, good. All right, so now I'm going to do the inverse tangent of 923 divided by 325, and it's 70.6. Okay. Degrees. So if I look, 70.6, 19.4, so that should be about 90 degrees. Yay! Okay, so that's a good plan. So those are the three missing sides, or the three missing things of the triangle. So when it says solve the right triangle, if it's giving you a side and a side, it wants you to find the remaining angles and the hypotenuse. Got it? Okay, that was super fun and kind of a mess. So let's see if we can keep this next one a little bit more clear. I'm going to go ahead and and I know there's a way just to delete this with a button somewhere. Somewhere. Delete. Here. There used to be a delete button. I'll just make it super small. Throw it away. Okay, that was fun. Okay, so let's do the next one. Now, this would be a great opportunity for you to pause this video and then try to do some of these on your own. And again, you might do that, you might not, who knows. So in an effort of trying to do this a little bit better, I'm going to do this. And I'm going to, okay. So, shoop, 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 shoop. All right, so angle A, which I'm just going to arbitrarily put here, is 31.3 degrees. Now, since I've labeled that A, the side opposite is going to be little a. Okay, so while I'm here, this is going to be big B, little b. Big B, little b, what begins with B? Barber baby bubbles in a bumblebee. That was fun. Okay, so something like that. So first of all, you got to get the picture right. If your picture's not right, the rest of the math's not going to be right, and then it's a sad, sad, sad day. But what you going to do? So we got this picture. And now we're going to do math, and it's going to be amazing. Okay, so we have to start off with trig right away. And we need to use probably a angle that we already know. So that would be the angle A. All right, so I know that the sine of this 31.3 degrees is going to be equal to the opposite over the hypotenuse. Now this is good because the hypotenuse is already given. So if you want, I'm going to break this down. You can kind of do this in whatever order you want. I'm going to kind of play around with it because I've just seen students kind of do it in different order. So let's say this is 5.1 or 0.5195. So 0.5195 is equal to opposite over, what was hypotenuse? 12.5. So you'll see people and they'll be like, I'll multiply both sides by 12.5. And then that gives them that the opposite side is, I have my silly thingy hiding down there. So opposite is times 12.5, oops, times this thing, and 6.49. Beautiful. 6.49. Okay, so that's the opposite side. Okay, and in our case, that's, I guess I should have called it A, is the opposite side. Okay, can you kind of see how we're doing this here? So if you were kind of stuck before, but now you think you know what's going on, try pausing the video again and working to get B. And pretending you did that. I'm going to go ahead and I'm going to use cosine to get B, even though I don't necessarily have to. There's several other ways to do it. 31.3 degrees is the adjacent over the hypotenuse. And again, if you did this a different way, that's totally okay. Whatever way makes you happy is I mean, it gets the right answer. You can't just be like, but this answer is 7 and it makes me happy. 31.3. So we've got 0.8545. And again, I'm not necessarily rounding. And I wouldn't, especially if you don't have the ability to go up on your calculator, over 12.5. Multiply both sides by 12.5 again. And you get 10.7-ish. Woohoo! Okay. So this is B, which is the adjacent side, is 12.7. Now, if you want to do a check, I can do a check to say, does A squared plus B squared equal C squared? And if it does, that means that I've probably done the right thing. Okay, so basically, does A squared plus B squared, does that equal C squared? Yay! Okay, so that means I've probably done the right thing. My answers are probably correct, and the only thing missing is B. And B is stay steady. B, come on, pickle button. There we go. B would be 90 degrees minus A, and let's just pretend that I don't trust myself to do that math right now. 90 minus 31.3 gives me 58.7. Beautiful. Woohoo! Beautiful. Beautiful. Okay, all that's going to go away. We're going to do basically the exact same thing again. But again, you're going to try to do it when you pause the video and see if you can figure it out. I don't know what happened to my delete button. So I'm just going to make it really tiny and throw it away. Okay. No, not that. Okay, so again, you want to make sure you have your picture drawn right. Doesn't matter what you draw as long as it's consistent. I'm going to call this one 71.2 degrees. That's not that. 71.2 degrees. And you're like, but before that was A. I know, now I'm making it B. So the thing opposite of this is B. Oh, and that one's 2.42. And that's all I know. Okay, so that means that this dude up here has to be A, so this little side here is A. That's not a very pretty A. Oh, that's much better. And this side is C. There. Perfect. Isn't that gorgeous? Okay. Now I don't have the hypotenuse anymore, which is sad. But I do have 71.2. So let's just go back to sine, good old sine. Sine of 71.2 is the opposite over this unknown hypotenuse. But the opposite, I happen to know, is 2.42. Okay. Now sometimes for some reason this drives students a little crazy. So if this math is bothering you, think about it as I had 3 equals 6 over x. Hopefully you can look at that and be like, so x equals 2. So however you would solve that, some people would do like this, and then they would go like this, and they get 3x equals 6 times 1. Okay. Some people would do it like this, and they would be like, I'm going to multiply both sides by x, and they would get 3x equals 6. Some people are just mad geniuses and it'll be like 6 over x, and it'll be like, I'm just gonna flippy flop these. Okay, so, and that's all true. So however your brain works, let me make this different color so you can kind of see what I was doing. 3 times x equals 6 times 1. So however your brain solves that problem, get there, but don't be freaking out just because it's got decimal places or the word hypotenuse in there, okay? Just realize you're just doing a basic. So anytime you're doing math like this and you're freaking out, replace everything with integers and the letter x and see if you can still do it, because you probably can. You're probably just freaking out for no reason, because that's what we do, right? We freak out for no reason. And I've forgotten how to mass delete. I don't know what I'm doing. There. Okay. So, however I've decided to do this, ultimately I'm going to end up with the hypotenuse, which is, I guess, C, is equal to 2.42 divided by the sine of 71.2 degrees, which is pretty fabulous. Don't do that. And then I need my stupid dops. So I've got 2.42 divided by sine of something, sine of 71.2, ka-chunk. And look at that, it's beautiful, 256-ish. Love it. Okay. And then we're looking at the other one. So that was opposite over hypotenuse. We can do adjacent, opposite over adjacent, so that's tangent. So let's just do tangent. Tangent of 71.2. Oh, I should have encouraged you to pause the video so you could be like, yeah, that's not going to happen. Opposite over adjacent. So adjacent, which for us is just A, is 242 over the tangent of 71.2 degrees. And go grab this dude, and it's, thank you, 2.42 divided by the tangent of 71.2, and that gives me something 824.824. Okay, so again, in theory, a squared plus b squared, well, I guess technically that was a squared, a squared plus b squared should equal c squared. You know, good enough for the fact that I was rounding off a whole lot. I like it. I'll accept it. It's not like it was 7 and 92 or something like that. So I'll just, I'm fine with it. The other thing I want to do is I'm going to do the 90 minus 71.2 to get A. Doop-de-doop-de-doo. And see what I can do next is get, math. Okay, 90 minus 71.2 to get 18.8. Man, that one slide took like 45 minutes. What the heck? Okay. Beautiful. Beautiful. Okay, this is just a whole bunch of examples. It's going to be fabulous, but I think the rest of them will go a little bit faster. Okay. Good. Okay, this is one that's already got the picture on there for us, so hopefully, again, this one you should be able to do. Pause the video, do your best, see how far you can get. Now don't get freaked out here because we have thetas and phis instead of other things, or fees or whatever. It's all still the same thing. So I'm going to start with theta. Theta, sine of theta is equal to opposite over hypotenuse. And you notice how I've kind of stopped writing this out is because I feel like I'm getting better at this. And that's okay, that's the point. Opposite over hypotenuse, so the inverse sine of 14 over 33 should give me the answer I'm looking for, 25.1. So theta equals about 25.1 degrees. And this dude here, now if I'm trying to get it out of something I already know, I have adjacent and I have hypotenuse, so that gives me, adjacent over hypotenuse is cosine. Cosine of phi is adjacent over hypotenuse. So that's going to give me inverse cosine of adjacent over hypotenuse. Oops. Doops. Badoops. 64.9. I love it. 64.9. Now that should, if I want to do a check, 64.9, if I add these together, 0, carry the 1, 0, carry the 1, 90 degrees. Okay, they add up to 90 degrees. Good, they should. And then finally, I can do a check and see this remaining thing, n squared. This seems not as hard as the other ones. Equals 33 squared. Maybe that's just because it had the whatsy-doozles, the picture already drawn for us, and I just like having pictures. 13 squared, oops, that's, none of that's right. 33 squared? Oh goodness. 33 squared minus 14 squared. And then I want to take the square root of that. Can you tell I'm getting kind of like ready to stop doing these problems? 29.8. So 29.9-ish. So n equals about 29.9-ish. Now, if you want to do kind of a check, this number, 29.9, is less than 33, smaller than the hypotenuse. It's opposite the bigger one. So this is 64.9, and this was 25.1. That's another thing you can do to kind of check. If this is 29.9, not degrees, it's opposite the big angle, so it's the bigger side. So you're like, oh, okay, it's opposite the bigger side. It's a bigger number, but it's not as big as the hypotenuse, so you know that smells decent. I always wondered why people smelled math. All right, Fumos, I think Dosmos for the win. Okay. All right, so now you should totally be able to do this. So pause the video, see how far you can get. And you totally did that, right? All right. So sine of 72 degrees equals the opposite, which is 61, over the hypotenuse, which is n. But we are so good at this now because we can rewrite it as 61 over sine of 72. And I'm too lazy to get out my calculator right now, so I'm going to go ahead and write the other one out. Let's see, if I've got 72 opposite over adjacent, that would be tangent. And you can pick anything you want as long as you end up with the right answer. It's kind of amazing like that. M equals 61 over tangent 72. And in theory, phi should be equal to, okay, I can do this one in my head. Well, not in my head, because doing stuff in your head is hard. 18 degrees. Okay, I really should have been able to do that in my head. Okay, that should be that. All right, so let's see if we can get those numbers really quick with our phony the phone. No, this isn't a phone. This is a calculator. 61 divided by sine of 72 is something. 64.1. And 61 divided by the tangent-y thing. Wait, no, not that one. This one. 72 equals 19.8. And let's see. What are my checks? Hold on. I'm going to go for my check. Is it true that 61 squared plus 19.8 squared, this is a 1, and that's a 9. That's terrible. What will the neighbors say if they see those numbers drawn like that? 61 squared plus 19.8 squared, is that equal to 64.1? Well, it's bigger, so let's hope so. 61 squared plus that 19.8, since I just have it right there, I can use it squared. Is that equal to this giant stupid thing squared? Good enough. I love it. Actually, not good enough. It's, perfectly wonderful for as much as I care, which is far less than 10 sig figs. I care far less than 10 sig figs, and that's how much accuracy I have. Okay, and life would not be complete without, oh my gosh, how many of these are there? Word problems, so many word problems, because word problems apparently are important for science. I never understood that. Why can't we just use math and do math for the joy of doing math? Okay. I'll let you read this. I'll draw a picture. One leg is 932. Hypotenuse is 14.9. Find the smaller acute angle. Find your face. Sine theta equals opposite over hypotenuse. Okay, I feel like now it's just being a brat, right? Is it just me? You know, for someone who potentially wrote these slides, I'm being very judgy. Past me was being kind of a brat. 8.7. 38.7, so other angle, and it wants the smaller one, right? So the other angle is 90, 90 minus that. So it wants the smaller one for who knows what reason. Yay, done. Okay, that wasn't too bad because that was kind of like a word problem, but it was just math. Oh, here's another fake word problem. I can do that. Derp, 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 derp. Hypotenuse is 194. One angle is 53.4. Find the shorter leg. Oh, okay. So the shorter leg is going to be opposite the smaller angle. Okay. So we could actually do less work if we go ahead and calculate the smaller angle. Not that we have to, but I'm going to do that anyway. Minus 53.4. 36.6. They probably could have done that. There's stuff everywhere. 36.6 degrees. Okay, if I want the shorter leg is opposite the smaller angle, so it's going to be this dude. And now I can just use sine again. Sine. I guess I could have used cosine from here, but I didn't. Cosine takes more thinking, and I'm been recording too long, and thinking is dumb, and I don't want to. X over 194, opposite of our hypotenuse. So x is 194 times sine 36.6 degrees. 194 times sine of this thing, and I'll get an answer which is 116. And I could probably work out the other one just to make sure, but I don't know how much I care. Oh, 194, I guess I do. 194 squared minus 116 squared. And if I took the square root of that, I'd get the other leg, which is 155. So clearly that one's shorter, but I knew it was going to be anyway because I'm kind of a genius. Okay, please let there only be one more problem. I think I promised you 3 more, and there were like, or dos mas, and there were like cinco mas. Anyway, okay, this is the last one, I swear. And I mean, you're still here, so obviously you care. Okay, zip line set up from a large tree to the ground. Seems like this zip line becomes much less fun starting about here. Okay. The zip line makes an angle of 18 degrees. 18 degrees. And is anchored to the ground 12 meters from the base of the tree. Thank you. What is the height to the top of the zip line? Height. What is the length of the wire needed to make the zip line? Length. Oh, okay, this is still just a stupid triangle. Here's my right angle. Angle. Beautiful. I don't like the way I wrote that. That's not very pretty. That's not very pretty either. I can't write with an eraser. Length. I can't write apparently in cursive at all. All right, let's do this, and then we can stop complaining and we can go get ice cream. Okay, so I have this 18, I have height I need, and I have the 12. So I have opposite, and I have adjacent. If I have opposite and adjacent, that makes toad. So I have tangent. So tangent of 18, oh, this is going to be dumb because that's where my calculator, I can move my calculator, is opposite over adjacent. So again, h equals 12 tangent 18. I can also do cosine. I can say cosine of 18 is adjacent over hypotenuse. You see what I did there? I did something different. I haven't done that one before, but I can do it. So I've got that. The length is 12 over the cosine of 18. Okay? So that'll be great. It'll be wonderful and happy, and we're going to have a great time, and then we're going to turn this stupid video off and go do something else because in the name of all that is holy, this is taking forever. Okay. So we have h is 12 times the tangent of 18. No, see, this is where dumb things happen. 12 times the tangent, there we go, of 18. And 12, so that's approximately 3.90. And the length is approximately 12 divided by the cosine of 18, which is about 12.6. So let's make sure those numbers make sense. Do I have that 12 squared plus 3.9 squared equals about 12.6 squared? Let's do it. And then we'll be done. We can go get candy, and it'll be fantastic. Squared, pachoo. Does that equal this thingy? Squared, pachoo. Yes. Okay, I'm so happy. I'm done. I've answered all the questions, and I don't even really care what the questions were asking because I don't care. I just like to do math problems. But yay, this is fantastic. Okay, so I hope you had fun with trig. I know it seems really silly and it's a whole lot of work, but the more comfortable you get with these, the faster you can turn them out. It's going to make your life so much better as you proceed or progress through your STEM classes. So you got this. You can do it. Have fun. Bye.